Good afternoon, everybody. Welcome back to another live stream. I am sliding into this one hot today. And what I mean by that is I was working on this code up until the very last second and I did not quite finish. But the good news is it's 95% done and the last 5% is simple enough stuff. So welcome to the stream today. So this is going to be a fun one today. It's going to incorporate learning new things of LangChain. It's going to incorporate some other LLM related sorts of generative AI sorts of things. So yeah, I'm excited to dive into this. So let's. Oh man, I'm not even 100% prepared. I'm thinking about other things that I didn't even get prepared quite yet. Let me pull this one thing up here really quick. All right, so I want to pull up XAI model card. X.AI model card. Okay. All right. So let's go ahead and talk about what we're gonna be covering today. That is this is a beginning introduction to LLM benchmarks. Again, I apologize. Sliding in here late, I would have liked to have been a little bit more prepared, but I'm not. So LLM benchmarks. So basically, like what I want to cover. Actually, let me just go ahead and share my screen to show you what I've just pulled up. So this is the Grok 1 model card. And most of these, well, I guess there's not enough information on here that I was looking for. Okay, here we go. If you go through, not just Grok here, but I just picked one, Grok here at random. If you go through model cards like these to understand like the different performance benchmarks and stuff, you will see these sorts of numbers and things tossed around pretty frequently. And so I thought it would be an interesting sort of thing to go about understanding what each of these are, because like if you're, I don't know about you, but for me, like I actually did not know what most of these are. I know what most of them are now, but I wanted to see like what are these things, a more deeper dive analysis on like how do you calculate them, what they're intended to score, and basically, and also just how many of them are they're out there. So what I did like 2 weeks ago is I went through a bunch of different model cards. So I went through like X.AI here. So you can go to GPT-4 for model card. Like basically Google whatever kind of model card you want. It might come up as something sort of different. So this one's called system card. But if you scroll throughout here, you'll eventually find stuff on like the performance of the model. So like if I scroll down here toward the bottom, it's somewhere in here, but like let me just do a control F and look for it. Wait, oh, there we go. MMLU. Okay. Maybe that was the one I was looking at earlier today, but anyway, but basically the idea is if you go in here and look at any of the, or performance, like if you do GPT-4 performance, you will eventually like come across like different metrics and stuff that talk about like the various benchmarks and stuff. Okay, so okay, here we go. Now these are some more standard ones, like the SATs and whatnot that we humans take. Okay, here we go. This is sort of what I was looking for. So you can see here, we have all these different benchmarks. So I went through a bunch of these and I thought, okay, I'm going to do a blog post that would cover all of these. And then I hit the 30 mark, meaning I found over 30 of these different benchmarks so far. But I'm finding that there are some commonalities. There are like some ones that show up more often than not. And then there are ones that are designed for different sorts of things. And even you can even start to see it a little bit here. And the one we'll be covering today is this one at the top here. So I'm going to skip past this one real quick. But you can see under this, with the smaller text, with this gray like lettering, you can see like human eval, for example, is checking for things like Python coding task, or Wino Grande here is looking at common sense reasoning. And then, so yeah. And so the idea is I wanted to write the code to see if we can you calculate these all very easily. And the interesting thing that I'm finding out, or maybe this is just bad luck, because I'm only starting with MMLU. I have not started looking at the other ones yet. There is not like a clean, here you go, run this thing sort of thing on the internet. Now there is and there is not. So so let's go ahead and just get into talking about MMLU. So what is MMLU? So MMLU here, it stands for or measuring I'm sorry, massive multitask language understanding. And what the idea here is there's 57 different topics. Yes, 57 different topics. So these are range across from business ethics. I think there's like some high school math in there and whatnot, and like asking all these sorts of questions. And these are multiple choice questions. So it asks the question, and then it'll give you 4 choices, and then it will give you the actual answer. Now, you're not supposed to give the actual answer to the large language model, of course, but the idea is, can the large language model guess correctly that answer? So and for context, we will get into the code, and we will start to show what some of this data actually looks like, including how to download it and whatnot. But yeah, so you will see some of these questions here in a short bit. So this is the original repo that is created here. Yes, this person, Mr. Dan Hendricks here. So he's I guess he and a couple folks over at the UC Berkeley there in 2021 put this together. Students, I believe, really impressive for students, but he just named his repo test. So that, yeah, I think that's interesting and a little bit funny, but anyway, so this is the official repo. Now, the interesting thing about this is that there's actually been different flavorings of this MMLU that I've come across. So Hugging Face, they actually put a blog here that really does a great job of talking about all the different flavors, and you can even see that they talk about like 1,001 different flavors. But really, I mean, so you can go throughout this whole blog. I'm not going to, but it's a very good read. But I want to focus on this little section right here, because what they found in essentially is that there's 3 different kinds of like MMLUs, and it's basically these 3 columns here, and you can see that they're very similar. Now notice that, so let's talk about what the differences are here. So you can see here that in the original implementation, that you start off with this 0. So this is what we would refer to as a 5-shot prompt. So we have like the 1 shot, 2 shot, 3 shot, 4. Well, I guess they might be calling this 1. So 1, 2, 3, 4, and then 5. Unless you did it like this, like the one over here on the right. This is truly like a 5-shot. I guess you could call this a 6-shot. But anyway, so you can see that they're like, so there's a little bit of meta prompt like right before here that is guiding some of these, and it's a little bit different between these 2. And then like on this 3rd one, they actually just exclude it entirely. And then you'll notice here like within the original implementation that like you have the word question, or you have the word question in the other 2, but you don't have it in the original one. And then you might have like choice support here. So it's like really subtle differences. I mean, I guess they do have some sort of an impact. Now, the interesting thing here is, so this link here, this Ulmer PR. So what this person did was they forked off the very original Python script here and refactored it a little bit to work for Hugging Face, which is nice. However, I think it's kind of funny that I noticed in here, like where they're noticing to spot the differences, a few differences, Helms adds an extra space. They're basing this off of this person's PR. When I look at the original implementation, this person did it wrong. And when I mean they did it wrong, it's really, really subtle. There is actually an extra space after this line here, and you'll see why it's. In fact, I'll go ahead and just show why it's so subtle. Where is it encapsulated at? I know where it's at just because I've seen this. I've looked at this code way too much over the last couple of days. It's somewhere right in here. Yeah, it's right here. It's these 2 characters right here. So you could see that this is the extra line break that this person did not include. So, yeah, so that is, but no, like, I don't know that actually impacts the performance of whatever this is. But so yeah, there's 3 different flavors here. So what I thought would be interesting here for today is to see if we could implement this original flavor here. And actually, so the way I'm trying to do this is in using, again, we're going to use LangChain here. And the idea with LangChain here is that we can, basically these other implementations, because they're so similar, it would not be hard to slide in another thing here that basically said, okay, if I wanted to do the AI harness implementation or the Helm implementation of MMLU, we could do that. I honestly, I did not delve deep far enough to understand the true benefits of one versus the other. When I look at some of the, so it does have some stuff up here talking about the differences. I didn't see like, yeah, you can even see it kind of here. Like, ignore some of this other stuff, like these other ones, because that's not the same. It's all very, very, very close. Yeah, maybe maybe somebody who actually built these could better explain that, but I'm not the right person to explain that sort of thing. Okay, so let's go ahead and just get into the code then. All right, so there's a lot of code that we got today. So, just for context, I am going to be using the OpenAI API, the public-facing one, with my own personal API key for like the back end of this. And I would like, we're going to set this up in a way that, again, we're going to use LangChain, and you can use whatever sort of LLM you want. But that's just the one that I'm going to be using if you want to follow along more closely. All right, so we got a lot of imports. Let me go ahead and make this a little bit bigger for y'all. All right, so we're going to import some of the standard libraries: OS, JSON, YAML to load my keys. We're going to import some of the standard libraries that we use in data science in general. So that is import NumPy and pandas. Okay, import NumPy as PD. That could have been bad. Import pandas as PD. Why is it not selecting my kernel? All right, there we go. And then, is it? Okay, now there we go. Those squiggly lines were bugging me. Okay, and then, all right, so this next one here, you may not have downloaded. So this next one, actually, let's go ahead and cover it over here in the browser, is the Hugging Face datasets library. So let me go ahead and go into Hugging Face. And then, so this is the Hugging Face main like hub area. So we're going to go into the datasets, and then just to show you which one we are going to be using. So we're going to use this one because this is the official one. So again, this person, Dan Hendricks here, he's been kind of facilitating this. He is now the director of this organization called like Center for AI something, but it's CAIS for short, which is why it's here. So this is the official one. You'll find other ones out there. I don't know what the other ones necessarily are here, but we're going to be using the Python client to actually download this instead of doing it like a direct download. Which is why I had to do a lot of refactoring of the original code, because he had it's a little bit different of how he set it up here on Hugging Face versus how he set it up with the original implementation. But no worries, we are going to work through that. All right, so what do you got to do to get this working? You just need to install the datasets library. So I think that's Hugging Face datasets pip install. I think that's just yeah, pip install datasets. Okay, and so then after you've done your pip install of your datasets, then we are good to go, or continue forward, that is. All right, so so we are going to, from datasets, import load dataset. All right, and then our last two here, we are going to load up, like I said, we're going to be using LangChain throughout this project, so we're going to be using from LangChain, OpenAI, import chat OpenAI, and then from LangChain.prompts import human message prompt template. Okay, all right, so that's all of our imports. All right, so the next thing I'm going to do is a little bit of notebook setup. So again, like I said, I'm going to be using my own personal oh my gosh, my mind just went blank, my OpenAI API key, and I have it saved over here in the sensor directory that does not get pushed up to GitHub. So I'm going to just reference this as such. So with open, oh my gosh, can't type, keys / API keys .yml YAML as f API keys dot equals YAML dot safe load f. Okay, so that is loading up my keys into like a little dictionary there that you cannot see, kind watcher, because I don't want to have to rotate these things. Okay, so all right, next thing we're gonna do. So like I said, these are the MMLU is a multiple choice test that does ask A, B, C, D sorts of questions. They are all A, B, C, D that I can tell. And the reason I say that I can tell is, well, I guess I won't get into it, but in the original code, like there's a kind of a weird little thing in there that like kind of lends to the idea that there might be some answers that are longer or shorter, but in my experience, there's not been. So again, I've not necessarily finished this project, so I could be wrong. But anyway, we're going to set these values statically. So we're going to call these MMLU choices equals A, B, oh my gosh, come on, C, D. Okay, so those are set. All right, now let's go ahead and set the LLM itself. Now let's talk about what we're going to be setting here as we go. So I'm going to call this LLM. We're going to call this Chat OpenAI. Again, this is probably going to be different per model, and this is something you'll have to check that if this functionality is even available for your model. So what we're going to be doing here is we are going to be extracting the log probabilities from each of the predictions as well. And what that means is, so like basically like you can actually, with some certain models, you can get the top sort of tokens that it was going to return. So like, let's say I'm going to fill in this blank at the end. I like to drink blank. Then the log probs, if you have the top 5 log probs, they might be water's number 1, coffee's number 2, soda's number 3, something else is number 4, blah, blah, blah. And the only reason that we're doing that is because we want to be able to see what the log probabilities are associated to each of the values if they exist. And if they don't exist, then we're going to penalize them. And I know that probably doesn't make sense right now, but it'll make sense as we get moving on further here. So I'm going to set my API key. So API key equals API keys open AI API key. Okay. Model name, again, this is going to be model dependent, meaning that like you do need to figure it out. So by default, this goes to GPT 3.5 Turbo. The default GPT 3.5 Turbo does not return log probs. So that's a little bit of a problem. Actually, so the one thing I do want to cover really quick that I'm a little bit confused about, I guess that's not, well, okay, I'm not confused about it. It's just that like, okay. I'm trying to think of how I want to phrase this. We're actually not going to do anything with log probs. Like the log probs actually have nothing to do with the MML calculation itself. All the MML calculation itself at the end of the day is how many questions did you get right? And we're going to take the mean of that. That's all it is. Yeah, so like I said, 57 domains, however many questions are associated with those domains. And we're just checking how many times did you get it right. That's how simple this benchmark is. But the nice thing is it does kind of give a sense of like the breadth of knowledge. So like that's where these log problems can come in handy if you want to drill down and do like a further deep dive analysis, which is why it is still important, why I'm still going to derive them, is like if you wanted to do a visualization to say like, okay, overall we scored an 89% on MMLU. However, we noticed that it does really well in math, doesn't do so well in business ethics. Because it's doing insider trading or something like that. But so it is still useful. So I do want to call that out. This is easily the most complicated part of this project. Like if we were just doing a straight calculation of the true false values to get the overall MMLU score, that is not hard. That is very easy. But trying to do this log prob thing is a little bit, I don't want to say hard, but it's a little bit tedious, but it's still worthwhile in the end. So unfortunately we can't do like GPT 3.5 Turbo. What we are going to have to do is there's actually an updated variant that will work for this. And that is like, I think it's like 11.05 or something like that. I don't know. I'm actually just going to end up using GPT-4 because I'm lazy. Too lazy to go figure out that number. All right. We're going to set the temperature to equal 0. So what this means for like, if you're not familiar with what this value is the lower this number is, the more deterministic the result, meaning that we are not trying to expand into like this wider domain of different probabilities that we could absorb if we set this temperature value to equal to something higher. And let me, I know that probably doesn't make sense, so let me re-explain that in a simpler way. So like imagine you're writing a book or like a fiction book and you want it to be really creative. You might want the model to choose more flowery words or different sorts of words. So you might turn the temperature up because it's going to have a different, broader sort of selection of words that it can choose from. Whereas if you set the temperature to 0, you are most likely going to get the same results every single time because it's always going to pick the most high probability values and ignore some of those other flowery or more descriptive sorts of things, stuff like that. And not even just that, but other sorts of tokens. Which also is an interesting point because I don't know, like this benchmark is referenced so often, and like again, I need to read the full paper on this. I've only read parts of the paper, but it makes me curious, like why, like when these people are calculating these things, are they revealing that they're using like a temperature 0? Because like for example, like GPT today, the public facing chat GPT, the default temperature I believe is 0.7. Okay, well a 0.7 temperature rating on an MMLU like analysis, I think it's going to get a drastically different result than a temperature of 0. So I just want to, and I just want to call that out because you know, they're going to measure it on this, but this is not the one that you're playing with. Like the one that you're playing with is 0.7 unless you know how to go and tweak that appropriately. So I don't know, it's a little bit deceptive, and that's sort of like the meta analysis that I'm finding out with all these different LLM benchmarks is they're all a little bit deceptive. Like they're not bad. Like I don't want to be, I got to be clear about that. I think they all can measure good things and you can get like general analyses of these things, but I wouldn't pour my I wouldn't stake all my bets on these things to actually measure the accuracy of these things over time in a very precise sort of manner. Like it's a good for a general understanding, but it's not good for like super precision, I don't think. But again, I need to read that paper. Maybe I could be wrong about something. But okay. All right, that was me rambling. My apologies. All right, so back to here. All right, so we only want to return a max tokens of 1. So again, this is a ABCD sort of thing. So this is where like we just want to see that it's going to answer right away. And again, this is another one of those things where it's like, is this test really measuring the best sort of kind of thing? Because like what? All right, let's say like we do give a like the model a question and like one of these multiple choice questions. We actually demonstrated this in the last live stream with like Mistral versus OpenAI versus like Anthropic, and we demonstrated that Anthropic's a little bit talky. So how's Anthropic going to do here? Because like with a multiple choice test, they might get it right, but they might say the answer is A. But that first token is not A. That first token is the. So like I guess yeah, like I don't. Yeah, I guess I don't know. Maybe I shouldn't be so critical. I think these are worthy considerations to bring up. All right. So we're going to set max tokens at 1. Now, we do have a couple of other default parameters within chat OpenAI, or like the baseline OpenAI chat, like if you were just not using it with LangChain. But for some reason, LangChain throws some of them into this model keyword arguments quirgs thing here. So we're going to throw a couple more things in here. So we already talked about these a little bit. So we're going to turn on log probs and true. We're going to set that to true. And then we are going to set get the top log probs 5. So this was another big change from the original implementation. So again, but to be fair to the original implementation, this was created several years ago. But the original implementation here, where is it at? I forgot what I was doing. Oh yeah, the top log probs. All right, so when he calls it, so this is the old syntax anyway. Like this is a very, like this syntax is outdated. He's getting 100 log probs. OpenAI has definitely cut back on that. Like, I don't know if you, like, if they, like, so many of these models, like, he actually, if you look in here, he's testing out several older models that actually are not, like, don't exist anymore. Well, they do, let me rephrase, they do exist, but, like, OpenAI is not hosting them anymore as of, like, a month ago. So maybe those did return 100 log probs, but let me tell, like the max log probs that like GPT-4 or 3.5 will give you is 5. So it's drastically lower. And again, like, well, never mind. Like we've already gone enough about that, but yeah, so basically I emulated these sorts of things. Engine here represents model. Echo here is not really necessary. Like, I don't even know if this is still a parameter anymore, but basically it's saying, okay, when I give you the input prompt, echo it back out to me. I don't know why you'd necessarily need that. So yeah, that I had to do, a bit of refactoring to get some of this stuff working, especially with LangChain. But again, all that stuff is worked out. It's just some of the last bit of stuff that we need to wrap up here in the remainder of the live stream. Okay, so that sets the client there for the LLM. So the next thing we want to do is we actually want to set our prompt. So we're going to be doing the original MMLU prompt template, and we're going to set this again using LangChain. So the way that LangChain likes to use things is it'll take the string that we are going to create here, and within the string we're going to set values with inside curly braces, and then that will be like the input values that we can later pass into this sort of string here. So this will make sense here once we start to get going in here. So the following are questions with answers about formatted subject. Okay, and if this, again, don't worry too much about what this means right now. Basically, like, so this is going to be where the placeholder for the subject domain that we're covering. So this will say abstract algebra, or abstract algebra, business ethics, whatever. It'll say that here per the prompt. All right, so that is the first part. Again, we cannot deviate from this. Please, we don't want to alter any of these words because then we want to stay true to the original prompt here to get the replicable results. Okay, so we're going to do a double space as opposed to what the Hugging Face people thought here. So we're going to do the double space, and okay, and then we're going to slot in the choices. All right, so what this here is going to be the question itself. So you can imagine what is what's the capital of Illinois? Then choices here, these are going to be our ABCD choices that are going to reside on each of the individual lines. You'll see how we work that out. But basically, this is going to be like, so again, if questions here is what is the capital of Illinois? Your choices might be A, Chicago, B, Springfield, C, Decatur, and D, Bloomington. And so the correct answer would be whichever one Springfield is that I just said there. Okay, so now let's go ahead and wrap this into an actual MMLU prompt template for LangChain. Prompt template equals human message prompt template from template, and then we're going to pass in this value here. Okay, and that's it. Now, if this is a little bit confusing, so you don't necessarily, LangChain has multiple different prompt template styles. There's a system prompt template, there's the human prompt template, and then there's a straight prompt template. To be completely honest, I'm a little bit confused about what all three do. However, the one that I see most often for a actual non-system crafted prompt is human message prompt template. There's other ways to do it. This is just the way we're going with. To keep things simple. Okay, so that's setting the prompt. Now let's go ahead and load the data set. So we are going to be, again, loading this data set up from Hugging Face. So the way that we do this here, so if you come on over to the Hugging Face page here, it'll actually conveniently show you how you can load this up. Now we're actually going to add some special parameters in here because this actually doesn't work like this. And I'll share why here in a minute. So let's go ahead and start getting this up. So I'm going to call this MMLU dataset equals load dataset. And then we're going to set the path to equal that CAIS/MMLU. So again, that CIS stands for Center of AI Society. I'm going to screw it up. It's a nonprofit that this person runs, or is the director of now. And then name, we're going to set to be equal to all. I can't remember now why I had to set this parameter, but I did have to. So I'm not going to look it up right now, but just be aware, you do have to have that there. This next one is not important, but I do like to set this. So I'm going to set my cacher here to be test data. Okay, hold on. I want to do something real quick because I wasn't planning on doing this. All right. Dang it. I didn't mean to do that. Oops. All right. Well, I guess that was quick. All right. All right. What did I just call this? All right. Test data. All right. Make their test data. Okay. All right. So what this parameter does is it sets the location of where it's going to download your data to. Now, by default, it goes to a system path on your computer that's kind of obstructed. Like, I actually did not know it was there. And I kind of don't like that it's there, because it's one of those bloat things where if you start filling up those weird sparse locations on your computer over time, and you don't need to persist these data sets over time, then like it just bloats your computer. So the reason I like to set a cache dir like this is because then I know where that data is at, and if I know I don't need it anymore, I can just delete it. But this is not a required parameter. It's just one that I like to have on. Okay, so but the primary one here that where I was saying that like that code that Hugging Face shared does not work out of the box is this line here. So this is trust remote code, and I don't really understand why we need to have this. So what this parameter here is doing is basically saying, okay, within this data set, there's some code here, and by default this is set to false. So we're just gonna let you know, like if you were to try to, well, let me go ahead and show you. Let me go ahead and try to download this. It's gonna. Why is it? It did not work for me the other day. Oh my gosh, I had to have that set to true in order to get that to work. Okay, so you can see I have no idea why that just worked, because the other day that did not work for me. All right, anyway, so I did have to set that, and then the other thing I want to call out here, and I guess I'm glad I did do this, is you'll notice that it downloaded 3 different data sets here. Let me take a sip really quick. Okay, so the 3 different data sets here, you'll notice there's an auxiliary train, a test, a validation, and a dev set. So the primary MMLU data set is run on this test split here. So that's this one, the second one here. I don't necessarily understand what the auxiliary train is for, because the way I read it, and you'll notice that there's a lot of files or a lot of records associated to it, is that like it's supposed to be used for training purposes, and then that would make sense why there's a validation split here. It's just that like I don't know, maybe for fine tuning, like if you wanted to test a fine tuned version of MMLU, I'm not really sure what this is for, but all that to say, we're not going to touch this one, and we're not going to touch this one. So you'll notice that we have 2 other splits here. We have our test split and our dev split. Our dev split is nice, obviously, because this is the smallest data set. And if we're just trying to get the code working before anything else, before we run it on the big data set here, then that's great. So that's why I'm kind of glad that we did this. So I'm going to set that split. So set the split to equal dev. All right. And again, so you'll notice that it did download this to the cache data set, or the cached file here. Oh, okay. So somehow, okay. All right. So even though I set the cache dir here, what I noticed now in this line here is I mentioned here that there's like the random place where it does have like the full cache of everything. Apparently it doesn't even matter what these 2 lines are, is if the cache is already in here. I don't know if I like that or not. I mean, it's obviously convenient, but then like I said, goes back to that idea of bloat that I was talking about earlier. But anyway, so let's go ahead and set the split there. All right, so we are downloading the data set. Now, this is not within a pandas data frame format. I like to work within pandas within the data frame. So let's go ahead and extract that out. Simple enough to do. And we're going to call this df MMLU, and that's going to be MMLU dot or underscore dataset dot to pandas. All right. So let's go ahead and take a look at what we got or are working with here. Might help if I put some parentheses there. All right, so we have 4 columns here. So we have the first column represents the question. The second column represents the subject associated to that question. And then the third column, you have the list of your 4 choices. So we have our 4 choices here. And then finally, we have our answer. And so the way I understand this, and I guess I never verified, but I'm pretty sure this is the case. But basically, like the answer here would be the index value associated to whatever is up in here. So all that to say is, so 0 would be A, 1 would be B, 2 would be C, and 3 would be D. And let's just verify that. So let's do a df, not value count. So there should not be, oops, I'm sorry, any more than the 4 values within the value counts there on answers. All right. Yep, and I'm correct. All right, so you can see there's more lefts and even split here. Okay. All right, what do we want to do next? All right, so the next thing here, so we're going to take this a little bit slower now. And what I mean by slower is we're going to get a little bit more granular. That way we can start to write some of the code more specifically without running all this data. So what we're going to do is abstract out just one domain of like the topics here. And so for context here, this dev data set, like I said, we have 57 different topics here. It has just 5 questions per topic. So when we pull out the subjects and stuff, you're going to see just 5 questions here. So let's go ahead and first thing first, we want to get a list of our subjects. So we have our subjects already in here. Here, let me just go ahead and show it again. All right, so the subjects are in here. Let's get a list of the subjects. So the way that we can do that here is we can go dfmlu subject dot value counts. All right, and so this is going to create all of our different value counts. Now, so you can see here, this is the subject value here is all the different subjects here. So how do we extract that out? Well, simple enough. We're just going to get the keys on this little dictionary here. All right, so that is our thing there. And then we're going to go ahead and sort this. I mean, it doesn't really matter, but let's go ahead and do a sorted on this, sorted. All right, and now you can see we have a nice clean list of all of our different subjects that we're going to iterate through. So let's go ahead and save that to a variable here. We're going to call this subjects. All right, and now, like I said, we're going to be just working with one single subject. What happened to my code? Oh, that was weird. That was odd. All right, so we have just the one single. We're going to just pull out the one single subject. It doesn't even matter. So let's go ahead and pull out subjects 42. I don't even know which one this is. So let's go ahead and look at it. All right, subject moral disputes. Okay, alrighty. Well, I guess we picked a winner today. All right, so let's. All right, so you'll notice that we have the underscore here. So this is what I was talking about with the formatted answer or the formatted subject. Is I'm going to create a new variable here now called formatted subject, and we're going to say formatted subject equals subject, and then we're just going to do a string replacement. So anytime we see a underscore, we're just going to replace it with a space, like so. So simple enough. And let's just go ahead and do a print on the formatted subject just to show you formatted subject. And there you can see we got moral disputes as such. Now let's go ahead and so we still have our full DFMMLU here, our full data frame here. Let's go ahead and slim this down now. Let's go ahead and filter out just on our subject here. So we're going to call this DF subject, and DF subject is going to be DFMMLU subject equals subject. So this is going to slim our data frame down just to our stuff here. Okay, so now you can see here we have just our 3 columns, and now we just need to do a lot of extraction of these things in here. So again, this is not a tough thing. It was just, I guess the longest part for me was just trying to figure out what the code was doing originally, and then like trying to refactor it into LangChain. Yeah, so you'll see some of that stuff here going forward. So let's go ahead and start iterating through this thing here. So I'm gonna start. So I'm gonna create 2 empty lists here. That like I'm gonna call this one subject is corrects equals list, and then subject probs equals empty list. Now, if you're wondering what these are, so these are going to be lists that hold for each of the individual subjects. Each question that we're going to ask, we're going to be adding a Boolean value to this list that says true if we got the question correct, or false if we did not get the question correct. And like I said, so at the very, very end of this thing, we're going to have a meta all is corrects, and then we're going to do a mean on that, and that's going to be the overall MMLU score. And then, so the probs here, again, we don't necessarily need it to calculate the overall kind of thing, but it's nice for data analysis. Now, we're not going to get as far to do the data analysis today, just because we're going to run out of time. Like, oh my gosh, I'm already 40 minutes in. So we're definitely not going to have time for that, but we're going to get through the good chunk of this today. All right, so for index. All right, well, let's iterate through each of the rows here to start pulling things out and start doing stuff appropriately with them. So for index, comma, row, in df subject dot iter row. So this is how you iterate over the rows of a data frame. You get your index value and you get your row. All right, so we're going to extract first the question. All right, so the question is going to be row question. All right, next up, we are going to extract the choices. Now, the easiest way to extract the choices, you'll notice here that we have this as a list here. Let me go ahead and show. So like a df subject. Let's just pull out the first row, and then let's look at the choices. Choices. All right. Oops. I gotta put ilock. Forgot that. All right, there we go. So these are the first. This is the list of the stuff that is here. So basically, what we want to do here is we want to do this whole A, B, C, D sort of thing. So let's go ahead and start showing you how to do that. So all right, so what we want to do here is we're gonna start with an empty string here, and we're just gonna keep adding stuff to it, and then we're gonna call all choices. We're gonna extract all choices from the row, just as we did above here, except it's coming from here now. So row and choices, and then so for index comma choice in. Okay, actually, you know what, I'm gonna do something for y'all over here really quick. So I'm gonna print all choices, and I'm gonna break. So that way we're just getting the very first row. Okay. All right. So this is the same thing that we're seeing from above here, except now we're just printing it down here. Now, so we're going to iterate through all these, but what we want to do is we actually want to get, put like the A, B, C, D sort of thing here. And so if you'll recall, we have this all the way up here, this MMLU choices that we set up here would be representing the values. So what we can do here is, as long as we know the index value associated to each of these things here, is we can do a little bit of a mapping sort of thing that gets that letter value very easily. And again, that probably doesn't make sense, but it'll make sense here in code. So let's go ahead and do that. So it's for, the way that we can do that to get the index and the value from a standard Python list is using the enumerate function. So for index comma choice in all, enumerate all choices. All right, so what we're gonna do here is choices. We're gonna append this, and then we're gonna do an F string here. We are gonna do, so our MMLU choices, we're going to pass in the index value, because what this is going to do here is basically going to say, okay, if this is index value 0, then index value 0 is going to look in here and see what this is here, and index value 0 here is the letter A. Okay, and then we put a period after that, and then we are going to put the choice itself after that, and then we're going to put a new line character there to add a new line to it. Now let's go ahead and print this out so you can see what this looks like. Choices. Might help if I printed the choices. Okay. All right. By the way, I am checking for questions on LinkedIn and YouTube. I unfortunately still don't know how to do that on X. I still need to figure that out. Print choices. All right. So there you can see these are the correctly formatted choices. And so the next thing that we want to grab out of the data frame here is we want to grab out the answer. Now, we are not going to append the answer back into this prompt, but we are going to do the comparison after the fact to see if the model got it correct. All right, so let's go ahead and do that. All right, so we're going to call this number answer equals row answer. And the reason I'm calling again number answer is because if you come up here, you'll notice that the answer is formatted as a number, so we can extract that out very simply. We're going to call this just ground. I'm going to call this ground truth, just to keep myself straight here. And so the ground truth is going to be whatever the MMLU choices is for the number answer, and so that'll be a letter grade. Let's go ahead and print number answer, and then let's print ground truth, just so you can see. So you can see for here. So we're pulling out the 0, and 0 maps to A. So, all right. So, all right, now we are getting into some of the fun stuff. All right, so now we are ready to actually start formatting the prompt using LangChain and actually passing it into the LLM. So what I'm going to do here is I'm going to create another variable called messages. So we got our MMLU prompt template that we're going to put in here. and then we're gonna call this function here format messages, and then we're gonna pass in some values, and these are the values that we actually set within the prompt above. So let's actually go ahead and remind ourselves of those really quick, what those are right now. So this is the original prompt. So we're passing in formatted subject, we are passing in question, and we are passing in choices. So again, formatted subject equals formatted subject, choices equals choices, and question equals question. Now I got those backwards, but I don't think that necessarily matters. In fact, let's just check. Print messages. All right, so you can see it did create this appropriately. So I mean, it's a little bit hard to read here, but this is creating an object that we're going to be able to pull from quite easily. All right, so now we are ready to invoke the LLM. Ooh, the way that we can do that here. So first we're going to set a variable here. We're going to call this LLM response. And then we're going to, actually, let's not even do that quite yet. What we're going to do here is we're going to do the lm.generate, and then we're going to pass in the messages equals, this is a little bit confusing. You do have to pass it in as a list. So we're going to pass in this messages here as a list here. That's just the way that syntax, that LangChain wants to see it. And then if we want to make use of the, well, let me go ahead and run it. I wonder if this will work. Let me see if I can print this. Okay. Okay, so this is just the raw object that LangChain gives back to you when you call the LLM like this. And so what we want here is we want to be able to dig in and extract all the information out of here. And it's just a lot easier to do that if you do it in JSON. And so fortunately, LangChain offers this capability. So all we have to do is do to JSON. Now, this is just in a string. So if we actually want to interact with it as if it's a Python dictionary, well, simple enough, we can just wrap this whole thing in JSON.loads. So, all right, JSON.loads. And now let's go ahead and save this thing as LM response equals, and let's go ahead and show you it. LM response. Okay. Now you can see we have a nice clean Python dictionary to play with here and start pulling some more information out. All right, so you'll notice that we have the log. Actually, let me go ahead and just do a print again down here of the LLM response. That way, because I think it'll pretty print down here better. Or not. I thought it would. JSON.loads. Can I put an indent equals to? No, I didn't like that. Okay, I don't remember what the syntax is there, but there's a way to do the pretty print. Okay, so, but yeah, you can see here that we've got the log probs in here. We have the actual, so this text value here represents what the actual guess is here, or I'm sorry, not what the actual guess is here, but the prediction is here. So let's go ahead and extract that out. I'm going to call this prediction. So prediction equals LM response. All right, so again, this is kind of funky. This is what I spent a lot of time just fiddling around with here to get right. And there's no clean way to do this. So you could see it's generations 00 text. All right, so in fact, let me just go ahead and show you that to be clear down here. LM response. All right, so if we were to just do generations, all right, so there we go. We have just the generations. Now you can see that we here have a curly, or I'm sorry, just like a list here. So that's where all right, so let's do the first item in that list. Okay, now we have another list here. I don't know why. So now and now we're starting to get somewhere. So then at least this one's pretty easy enough. We just need to grab out the text. So that's the actual ground truth, or the actual prediction, I'm sorry, that we're going to be comparing to the ground truth. Now let's go ahead and grab out the log probs, and that's just as hairy here, but not too bad after you do it the first time. Log probs equals LM response. All right, so generations. And just for reference, I don't have this stuff memorized. I'm obviously looking at another screen down here where I have my code that I wrote earlier. All right, so generation info, log probs. Yeah, it's like I said, it's a bit hairy to get to what you need, but it's here. All right, and then we're almost there. All right, top log probs. All right. Now let's go ahead and print that out just to log props. All right. So there you go. We have all the log probs. And like I said, within here is just the 5 that were returned because that is the limitation of the model. Based off whatever model else you use, you could have more than that. Obviously, this user over here, the person who originally created this test, apparently was able to get 100 at one point, but that is no longer the case. Okay. All right, so we're moving right along here. So everything that we've done so far took me well, not like a full week's worth of work, because obviously this is not my full-time job, what I'm doing here. But I'm trying to think, how many collective hours have I done in everything that you've seen here so far? I don't know, maybe 8. So we just breezed through 8 hours worth of my work in about 20 minutes or 30 minutes here. So this was not, some of the stuff was a big pain in the rear to figure out, but yeah, so moving on. Okay, so, all right, so so this is not an ideal format to work with, because what we need is the actual token value and then the token log prob, but it also included this bytes value here. I actually don't know what the bytes value represents here, but we don't need it for our purposes. So I'm going to refactor this a little bit. And so I'm going to call this, I'm going to create a thing in here. I'm going to call it token log probs, token log probs. I'm going to be making an empty dictionary. I'm going to simplify this down. So let's iterate through the each of the log probs here. And you'll notice that the log probs here, this is a list of dictionaries, not the easiest to kind of work with in its raw state, but very easy to refactor. All right, so let's go ahead and refactor this. So for log prob in log probs, token name equals log prob token. All right, token log prob equals log prob, and then finally we are going to set token log prob. Oh yeah, we're gonna set the actual value in the dictionary here. So token log probs is going to be the actual token name, and then we're gonna set the value to be the token log prob. All right, so let's go ahead and print that out just to maintain full transparency here. All right, probs. Okay, so there we go. Now we have a nice clean dictionary to work with here. All right, so now what we want to do here is we want to iterate through all of these here to see if we find all of the A, B, C, D answers. So this is actually a great representation here. I hope we get the same answer again, because you'll notice in here we do have A, we do have C, we do have D, we do not have B. And so what the way that the original coder implemented is that he gave it a penalized value. So you'll notice that a lot of these log probabilities here are like negative values. They generally don't go higher than -10 from what I've seen. So what he did, and what we're going to do here, is we're going to penalize it with a -100. So the way that we do that, simple enough, is just a little like, you know, iterating through some things here. So we're going to call this, I'm going to create another dictionary. We're going to call it ABCD log probs equals just an empty curly braces, and then we're going to iterate through the choices. So for choice in MMLU choices, all right, so if the choice is in the token log probs in the keys, so if it's in if it's in here, then we're going to set this value to be whatever this other value is here. So that's going to be ABCD log probs choice equals token log prob choice. Why do I feel like I didn't do that right? For choice and log prob dot keys. Hold on. Oh, it's because I didn't finish it. All right, we got to the point where I... All right, it's because I'm looking at my other screen. It's like, why does this not look right? And it's because it's not right. And so this is where I stopped, like right before this live stream started. So this is where I'm actually going to kill this other notebook and go back to my main notebook that I was working out of, because we don't really need... I just created this one just for your all's purposes, but this other one's a lot cleaner. So let's go ahead and look at it. All right, so... So you'll notice that like I've got more annotated markdown and all sorts of other things here. So one thing I did notice here is we are going to need to calculate a softmax value here next. Well, actually, you know what? Let me stop here for a second. So I don't want to. So this might be look a little bit different because it does have all these comments in here. There's nothing different here. We've been following along with the straight syntax. So your syntax might now look a little bit different, but just know it's just now I got a bunch of. There's a typo. There's a bunch of extra comments in here about what's going on. Okay, because I like to make things very clear. All right, so you'll notice the thing that I was kind of tripped up on is like, why am I trying to append the token log prob when it should be log probs? And now that makes more sense. And then I'm adding a fake penalty here. And this is where I did not get far enough. So I'm going to call this ABCD log probs choice equals, and like I said, we're going to make it negative 100. Negative 100. Okay. Oh, maybe, hold on, let me go ahead and restart and run on myself. Oh, I forgot that we changed our, oh, did I delete that notebook? Gosh darn it. I forgot that, oh wait, it was 42, that's right. I was, I forgot that we had changed the subject here. All right, so let's go ahead and restart and run that all again. Okay. Where did I print? Oh, it's printed out the token log probs there. Okay, but I don't want to print that anymore. I want to print out the ABCD log probs. All right. So now you and I are on the same page pretty much as far as coding. So we're gonna figure out the rest of this together. But the good news is like we're pretty much close to the end of like the code here anyway. So yeah, so you can see here that we printed out the ABCD log probs, and this did it appropriately. So this was correct. So you'll notice that we have the log probs here. Now, what we want to do here is we're gonna add. I already added this up here. I want to see if there's a better way to do this because this person just implemented it manually. But what we're gonna do is we're going to implement. We're gonna apply the softmax function to these 4 values. And so what that means is, so we have our list of the values here. So we have the negative 6.42, the negative 100, and these other values. What this is going to do is it's going to make all these values basically become percentages. So where all these values will now add up to 100. So let's go ahead and you can see that I've already got the code written here. I just had to comment it out temporarily earlier because I hadn't had this other code written yet. All right, so let's go ahead and delete some of these rows out. All right. So let's go ahead and print ABCD log or prob values. All right, so yeah. Why is it? What is the correct value? I don't even remember what the correct value is here. 0. The correct value is A. I guess it's kind of hard to read because it's in the scientific notation. But I think that this one is still the highest. I may be wrong on the softmax function. I thought I had that correct. Yeah, the numerator, denominator, the exponent. Let's go ahead and review that. Let's use our friend Perplexity to help us out with this. What is the softmax function? I feel really dumb because I'm confusing this with softmax, argmax, and so a couple other ones. Okay. As they can convert the scores into. Yeah, okay. I was right. It's just hard to read because it's in the scientific notation. So that's what this E kind of thing here is. It's basically saying, okay, you need to move the decimal place over a couple spaces dependent. So you can see here, it makes sense that B is really, really high because that would be a really, really negative, like a really, really small value. But I think if you actually were to add these up, in fact, let's go ahead. I think there's a way to do that. So sum of the ABCD prob values. Yeah. So they basically add up to 1. Like not exactly, but I mean pretty much there. Okay, so I was right. I'm not. I thought I was going crazy for a second, but I'm glad I got that right. Okay. Um, all right, so we got the probability values. All right, what do we need to do next? Oh, I don't have any code, so let's go ahead and slide in this, and let's continue on. And so we'll even go ahead and point out some of the differences that we've come across along the way. I'm gonna make this smaller on the left side. Okay, so and I'm gonna make this little. How to make it bigger without? All right, you're gonna be difficult, aren't you? All right, screen. I can't zoom out. What is going on here? All right, there we go. I don't like that. I don't know why I did that. All right, well, I guess we got big screen mania here today. So all right, so this is basically everything that we've done so far. It's just like we've done it a little bit differently than what the original user did. So I guess we just calculated the softmax. I guess what we oops darn it, didn't mean to do that. Oh no! All right, come on. All right, so I guess all we need to do now is check to the Boolean value. So that was going to be the next thing I did here. So I'm going to call this is true equals ground truth equals what do we call that, prediction? And so it should be false. And let's go ahead and print that out. Print is true. Okay, yeah, so it's false. All right, and that's basically it. I mean, like, what I mean that's it is now it's just a matter of plugging and chugging and just doing this over and over and over. Because all we're gonna do is, so let's go ahead and we'll go ahead and round things out, of course. So we're gonna go ahead and append these values now. So we're gonna say appending the final values, and then it's gonna be so what do we call these up here? So subject is correct. Dot append. Dot append is true, and then subject all subject what do we call this, probs dot append wait, what is he appending here? Is it just the probs? No, he's doing oh, interesting. Oh, so okay, I may have misspoken a little bit. So it doesn't look like it's just that the MMLU is necessarily doing a mean of everything. Like of all the questions straight. It looks like it's doing at first a mean of all the questions within the subject, and then it's doing a mean of the mean. So let's come down here. So like this is the original code that's doing the mean of the mean. So you can see that like this is where we're getting the exact same values. And then oh my gosh, why do I keep clicking that? And then we're saving this out, and then you could see that at the very end. All right, I need to stop double clicking. All right, and then that's what this is all doing. Okay, so that we really are on the home stretch here. All right. All right, so we've appended these. What else do we need to do? Where was I at? So coming back up here. So we've appended those. So that is just for the one subject. So that is all we have to do. Now we just need to, all right, we need to start wrapping this even further, I guess. All right, if we want to, well, I want to keep this like this. And actually, let's just test this out as is. So this is all just for one subject. Dot append is true. 0 we're given. Oh, yeah, it might help if I actually appended something. A, B, C, D prob values, right? Okay, so this is going to take a little bit to run because it's running all 5 questions there. Okay, so that wasn't too bad. All right, so let's go ahead and check this out. So subject is correct. All right, so we have a false, true, true, true. Okay, so not bad. You know, we got one question wrong in there, but the 4 other ones were correct. And now we can check out the subject probs. Now this one is not going to be as informative, but again, if we wanted to do some visualization things, and I think I might after the fact, but not within this stream, that's just going to take too long. Yeah, so you can see here we got all these. Wow, we got some interesting values showing up in here. Okay. And now we basically just wrap this thing in a big for loop, and then we just do it again. So I'm gonna, for yours all sake, because it's the actual notebook I'm going to be continuing to like do my work out of. I'm going to copy all this down, and then we are going to we're going to do the full thing. In fact, I'm going to call this running the full MMLU test or benchmark. I don't know what we want to call it. Benchmark. All right, so let's go ahead and delete that out. Let's go ahead and paste all that in. So now we just need to, all right, so we already have our, I'm gonna bring this back down. All right, and this is not the, like a Jupyter notebook is not the ideal place to do this, but you could see sort of why I enjoy using a Jupyter notebook in the beginning, at least, is because then you can start doing a tiny little iterations, and then after everything is done, then the ideal place would be to bring this out of the Jupyter notebook into an official Python script. So I just want to call that out there. So all right, so we have our list of our subjects. So for now, we're going to wrap everything for subject in subjects, iterating over all the subjects. All right, so for subject and subjects, what do we need to get? We need to get the formatted subject, and then we need to indent this entire thing. This is not going to be easy, is it? I should have just indented it all when I pasted it in. That was a bad call on my part. All right. Oh, come on, thing. No. All right. I guess we're gonna have to do this part by part. This is why it is not ideal to work in a Jupyter notebook. All right. There we go. All right. So now let's go ahead and start adding a few more things in here. All right, so okay, I'm gonna call all is corrects equals, oh, because we need to get the mean, that's right, of each subject, and I don't think that we didn't necessarily did that. Subject probs. Oh, that's because we want to do that after this for subject and all subjects. Equals empty list all probs equals the list. Okay, so then after all this runs, then we're going to iterate over, we're going to get the mean from all these, right? I'm just trying to think my way through this. Okay. For subject. Okay, so that's iterating. Okay, no. Oh, yeah. Okay. Yeah, that's right. Okay, so we have all this nested in here, and then with that within here, so it's not necessary. It's still one deep in here. So at the end of all this, we want to do a mean. So we're gonna do appending the mean of all the correct subject answers. To the meta, or to the full list of correct answers. All right, so we're going to call this, what is it? So we have all is corrects dot append np dot mean of the subject is corrects. All right, and then appending all the correlations. And I don't like the way this is, so I'm going to refactor this later because I would like to, and the reason I don't like it is because I would like when we append all the correlations together, I would actually prefer this to be a dictionary where you have the key being the subject name, and then the value being the list of the log props. So I don't like the way this is actually implemented, but that's okay. That's just a personal preference. Okay, so appending all the correlations, together. And so that's all probs equals np.array. Hold on, I'm a little bit confused here. Oh, he transformed it back. Oh, okay, so we got to do another little np.array there. Okay, np.array. So, okay. All probs dot append probs. All probs dot append subject probs. Okay. Now this is probably going to take a little bit to run. Now, I don't remember how many cells there are. So it was 5. All right, so let me do the math in my head. So 57, and it took about we'll say 3 seconds. So calculate 57 times 3 is what? It's a little bit over 150, so that's like 2 minutes. So we'll let it run for 2 minutes here, and we'll kill it if not. But then that will produce all of the is corrects here, and then the final score should just be the mean of all these means. I hope I did this right. All right, we'll find out here in a minute. Hope you all are having a good day. Yeah, I'm good. Yeah, just killing time here. Like, again, this is the very first time I've run this full thing, so you are joining me along with the ride. So you can see here, it's actually not too bad to implement this measure. And then the cool thing about this is because the way we've implemented it here is we can swap out this LLM here for anything that we want. And the reason this is important is you'll notice that we got some goofy syntax here to pull out everything. Imagine trying to program that for each of the individual models. So that is really where LangChain's giving us a lot of lift here. It's abstracting all that baloney away. And so we only have to do this one time. And if we wanted to test out like Anthropic, or if we wanted to test out something else, we just slide in a different LLM, and we're just on our way using this exact same syntax we got here. All right. I should have put a thing like that said, all right, completed so many x of x or whatever. All right. I wonder what this is going to do to my OpenAI bill. I don't think it'll be that bad. Like, but I just realized I'm using GPT-4 here. Oh, I should have used GPT-4 Turbo. I'm a dummy. All right, so we passed the 2 minute threshold. We'll give it. I will give it a total of 4 minutes, and if it doesn't complete, then I'm going to call it. But I think it will. It's just taking a while because it's going through a bunch of different questions. And this isn't even the full test now that I think about it. The full test is that entire thing. Like, this is just the small dev set. Oh, it finished. All right, yay. All right, so I was not too bad off with my math there. I thought it was going to be a little right around this mark. All right, so let's look at this. So all is corrects. All right, so now we have all these different things representing the is correct mean values. I think this doesn't really look right, if I'm being completely honest, because I don't know why. Well, I guess never mind. So let's look at the value number 42. Value number 42 should be yeah. Okay, so it is correct. All right, so let's because so value 4, and as a reminder here, I don't think I have this saved anymore, but basically, like, we had noticed that it was, of the 5 questions that was asked, was 4 were correct and 1 was false. So that is 0.8, and that is correct. All right, so that is correct. So now all we have to do to drum roll is get the weighted, calculate this thing here. Very easy to do. All right, so let's just call this weighted ACK. Weighted ACK equals np.mean. np.concatenate. So we're going to concatenate all these values together. What is this called? All is corrects. Zero dimension values cannot be concatenated. Okay. I wonder if we could just do it. Or maybe we don't need that. Mean is np.mean. What am I trying? Oh, just all is corrects. All is correct. Might help if I printed it. Print. Drumroll, please. So on our dev data set, GPT-4 got a overall score 55%. Now, again, this was just the day of data set, so don't go taking away anything from this, because this is obviously not the real one. And, we were using too low of values to get anything real, but basically on our dev data set, GPT-4 gets a big F. But that's it. And so you can see we didn't actually need the log problems, but this is where it would be helpful to see visualizations of okay, it did better in, like I said, in the moral disputes, but didn't do so well in the business ethics, but it did better in the math. And I might do that still, but again, we've been going for an hour and 15 minutes, and my voice, I can tell, just needs a break. So we're gonna call it here. I'm happy with my progress. Let me go ahead and push up these changes. I don't want this. I'm going to delete this out before I push up these changes. I was just doing that for demo purposes. All right, so delete. And I'm going to clean up this code too with more notes and stuff. But one down, however many more of these LLM benchmarks I want to go. So let's go ahead and push up my changes. So completing the MMLU calculation, but need to add notes. All right, so, and then I'm going to actually refactor this into a formal Python script too, but we're not going to do that live because I'm going to go touch some grass because my phone is telling me it's 61 degrees outside. Oh my gosh. I haven't had a 61 degree day in months. So it's apparently pretty nice outside, and my daughters are going to be getting off school here shortly anyway. So I hope you all enjoyed this live stream. I'm probably going to be doing more like these in the coming series. Now, one thing that we did not talk about today that I do want to cover at one point is what exactly is a log prob. I gave you, or I guess we covered what it is. How is it calculated? And that is a larger discussion of I alluded to this before. 2024 is going to be a big year. I want to put together a bunch of content on how to actually create your own neural network, or I'm sorry, not neural network. Well, yes, neural network, but your own transformer, your own LLM from scratch. Now, obviously, it's not going to be GPT-4 quality. We're not going to do anything that fancy, but we'll explain each of those steps along the way when we get to those points. Okay, so next week I will not be here. I will be in Chicago. I'm doing a public speaking course that I'm really excited about. My employer is sending me to that. So I'm going to be there next week. So probably not live stream next week, but maybe in 2 weeks or maybe next Saturday, because I'll be back by Saturday. I don't know. We'll see. I want to get back to doing these a little bit more frequently. I know 2023 we fell off a little bit, but we're going to get back on the wagon. We're accelerating. We're going ahead. And yeah, so hope you all enjoy your weekend, and I will see you in the next one. Thank you.